This lesson introduces trigonometry. Trigonometry is the study of measuring triangles. Here's a triangle. It's got a 90-degree angle, and it's got a reference angle, or angle that is being considered as the point of view. Let's look at the anatomy of the triangle. Across from the 90 degrees, you've always got the diagonal, which is referred to as the hypotenuse. Then, if we look through the reference angle as if we were looking from that tip, we would find the opposite side to be this side, called the opposite. And finally, the side that is adjacent to the angle is labeled the adjacent side. So knowing the anatomy of a right triangle is important because these sides will be referred to in various ways. Most importantly, trigonometry looks at the proportions between the sides. So think about this triangle. You have three sides. How can you make proportions between the sides? Well, you could take the opposite over the hypotenuse, hypotenuse over the opposite, opposite over the adjacent, adjacent over the hypotenuse. You actually have 6 different possibilities of dividing these. The key 3 are the sine ratio, so that's the full word, that's the abbreviation, and this is a term, so sine of theta, that's how that's read, sine of the angle name, and in this case the angle of reference is theta right there where the lady's looking. So that's how it's said, and the sine ratio is the particular ratio of taking the opposite over the hypotenuse. Now, you can also take the adjacent over the hypotenuse, and that forms the cosine ratio. So the cosine ratio of theta, which is the angle, is found by dividing the adjacent over the hypotenuse. And finally, the tangent ratio, tangent of theta, is the proportion between the opposite and the adjacent. So these ratios are helpful because once they're found, you can find all sorts of other things. And these ratios are often remembered according to the mnemonic SOHCAHTOA. You may have heard this before. It represents the sine ratio as being opposite over a hypotenuse, the cosine ratio as being adjacent over a hypotenuse, and the tangent as being opposite over adjacent. So what are the following ratios? What is the sine ratio of alpha? Alpha's right here in this particular triangle. So let's label the sides based on alpha. Across from the 90, you always have the hypotenuse, and then across from alpha, you'll have your opposite, and beside alpha, you'll have your adjacent. So, the ratio for alpha for sine, and think back to SOHCAHTOA to figure out what the ratios are, sine will be the opposite over the hypotenuse. In this case, that's 3 over 5. Try some of the other ones. Cosine of alpha. Well, cosine is the proportion of adjacent to the hypotenuse. That's 4 over 5. And tangent of alpha is the opposite over the adjacent, which is 3 over 4. Now, notice that if you change the angle, the reference point changes. Now the lady's looking from here. So now this is the opposite, and this is the adjacent. It switches. So be careful of what your reference angle is. Also notice that this is not 2 separate things. This is one separate thing. One whole thing, rather, because it's the sine of angle B. And the sine of angle B is the proportion between the adjacent, the opposite, and the hypotenuse. So that's 4 over 5. And what's cosine of b? Cosine of b is the adjacent over the hypotenuse, which is 3 over 5. And the tangent of b is 4 over 3. So we can make a few observations here. Notice that the tangent of the other angle, and notice that in a triangle, these all add up to 180, and because this is 90, these two will add up to 90 degrees, which means they are complementary angles. So notice that the tangent of a complementary angle will just be a reciprocal. The sine and the cosine will be reciprocals of each other. These are just interesting things to notice because it leads us to shortcuts in the future, but don't worry too much about that at this point. Okay. Now let's take a look at this dynamic sketch of a right-angled triangle with the opposite, adjacent, and hypotenuse labeled from the reference point A. Now this can move, so I'd like to explain what I've done here. I've created a right-angled triangle, and angle A is measured right here. It's 30 degrees at this point. Angle B is 90. So the measurements of the opposite, adjacent, and hypotenuse have been made in centimeters. And so when I drag this program calculates how long these sides are, and I can move it in various ways. I can say, oh, I just want to move this all around. Now, take a look at the ratios that are being formed. So the angle is maintaining 30 degrees no matter where I go. And look at how the ratios are not changing. So the opposite over the hypotenuse, the ratio is the same no matter how big my triangle is or how little my triangle is. The ratios are the same. This is a fundamental idea behind trigonometry, because if we know the angle is 30, we know that all the proportions of the sides will maintain the same proportion. So rather than tracking all the measurements, we're tracking the proportions. So this is going to allow us to find missing pieces, because if we know that the opposite over the hypotenuse, which is the sine ratio, is 0.5 for angle A of 30, then we can deduce that any triangle of angle 30 will produce a ratio of opposite to hypotenuse of being 0.5. So we can use that to our advantage when finding other parts of the triangle. Now let's see what happens if we change the angle. Notice if I change the angle of reference, the proportions change. However, once the angle maintains the same, all the proportions remain the same also. So this can be useful in problems such as finding the length of a lake. But how, you say? Well, let's take a look. Let's look at solving some triangles. So here's an example of a right-angled triangle with reference angle given as 50. So we can label this triangle according to the right triangle anatomy. So across from 50 is our opposite, across from the 90 is always our hypotenuse, and the adjacent in this case is x. Notice you could find that this is 40, and you could use that instead, but let's use the 50. So you label your sides, you choose your ratio that you're going to use in this case. We're interested in the adjacent and the hypotenuse. We don't really care about the opposite. So because of SOHCAHTOA, we know that we need to use the cosine ratio to relate these, because that's where our information is. So we want to fill in our information for the cosine ratio. So we know that the cosine of 50 degrees is going to be the proportion of x to 20. And in this manner, if we know what cosine of 50 is, which it's stored in your calculator, so try your calculator out, make sure you're in degree mode and find what cosine of 50 is. Cosine of 50 is 0.642787, etc. And that's equal to x over 20. So notice what we're doing is we're saying, what is the standard proportion that we know works for all triangles of angle 50? And how does this relate to our particular triangle to find our x? And then finally, we can use our cross multiply divide proportion solving knowledge to find what x is. So you can find that x is the same as your cos 50 times 20. And because I like to maintain accuracy, I just actually end up putting it into my calculator as 20 times cos 50, which is 20 cos 50, 12.86 approximately. Let's try this other example. You've got 90 here, hypotenuse, angle of reference, therefore the opposite, and the adjacent. So what do we need? We need something that relates O and H. Well, that's sine of 23, because sine relates opposite to the hypotenuse. So essentially we have a proportion here we can cross multiply and divide, leaving us with 30 divided by sine 23. Remember, sine 23 is just some number that you need to use your calculator to find. It has been programmed into your calculator. And finally we find it to be 76.8. But what about finding angles? Well, to find an angle, there's something also on your calculator that allows you to find what angle creates a particular proportion, and that's found with your inverse buttons. So let's check this one out. We'll follow the same thing. Let's label our sides. Our 90 gives us the hypotenuse, our angle of reference gives us our opposite, and our adjacent is beside it. In this case, we're looking at opposite and adjacent, so that means that the tangent of theta is going to be 30 over 40. So 30 over 40 is actually 0.75, so we know that the tangent of theta is 0.75. Now in our calculator, it has been programmed in that whatever the input is gives a certain output, and therefore it can find the reverse of that. And the reverse of that is given by either arctan or tan inverse of the 0.75 or whatever this was here. And you can do this for all the different ratios like sine and cosine as well. So when you type it in, you should get 36.9 degrees. So that's about 37 degrees. So if you're not getting that, it's likely because you're in radian mode instead of degree mode.